Hello students, now today I will explain question number 1 and 2 of exercise 3.1 of chapter 3, understanding quadrilateral. But before that I will give some information on polygons. Okay, this is very important. Now what is a polygon? Fine, so all of you, I request please write the definition in your copy. That is, it is a simple closed curve made up of only line segment. Okay, so there are some words that you have to be very careful about. That is, you see, what is the definition? It is a simple curve. I hope you understood what is a simple curve. We have discussed in our previous video. It's a simple curve and it should be also closed. That is, simple closed curve made up of only line segments. So these are the words that you have to remember, that what is a polygon? It is a simple closed curve made up of line segments only. Fine. So the expected figure would be what? Just a minute. So it would be, suppose, square, fine, rectangle, fine, triangle, or star also, no problem with stars, fine, with star also, no problem. That is, it should be like this. Okay, see, all the sides are made up of some line segments. All are line segments. Fine, I drawn it very badly, do not mind. So just leave this figure. Okay, so rectangle, square, triangles. Okay, even pentagon also you can draw. Regular this is also pentagon. That means 5-sided figure. So these are all simple closed curve made up of only line segments. Okay, circle is also a simple closed curve, but because it is not made up of line segment, so this will be not considered as polygon. Fine, so this is also a simple curve. See, this is also a simple curve. Fine, but because this figure is not made up of line segment, so this will be not considered as polygons. Fine. So now the next topic we'll study is regular polygon. Now what is a regular polygon? Regular means all sides and all angles should be equal of that polygon. Fine, that all sides and all angles should be equal. So that is, the example is equilateral triangle, square. Okay, so these are all the examples of what? Regular polygon. See, equilateral triangle means all the sides are equal. Square, all the sides are equal. In equilateral triangle, all the angles are equal. Fine, in square, all the angles are equal. Isn't it? You see? So to consider any polygon as a regular polygon, the two conditions need to be fulfilled. That is, all sides and all angles should be equal. It's not that all sides are equal but all angles are not equal. That particular polygon will not be considered as regular polygon, because see, in rhombus all the sides are equal, isn't it? In rhombus all the sides are equal but all the angles are not equal. So that is the reason this rhombus will not be considered as what? Not be considered as regular polygon. Even rectangle also. In rectangle, all the angles are 90 degrees, but opposite sides are equal. Not all sides are equal. So if you have to say any figure as a regular polygon, you have to consider these two conditions. That is, all sides and all angles. This two has to be there, fulfilled. All sides and all angles. Okay, then only you can say that this figure is a regular polygon. Fine. Now let's move on to irregular polygon. Now in irregular polygon, all sides and all angles are not equal, students. Are not equal. That means this time we can say that rectangle Fine. Right angle triangle or even parallelogram. Fine. These are all what? Irregular polygon. And why so? Why so? As because in rectangle, as I've just mentioned, that only the opposite sides are equal, but all sides are not equal. But in rectangle, all the angles are equal, students. That is 90 degree. But as since all the sides are not equal, so we'll not say this as regular polygon. Now in right angle triangle, only one angle is 90 degree, and rest of them are what? Less than 90 degree. So all angles are not equal, and even all the sides are also not equal. Now in parallelogram, again the opposite sides are equal. Fine. So you see, it is not fulfilling the first criteria, that is all sides are not equal, and even the opposite angles are equal. Not even all the angles are equal. So these all figures will be considered as irregular polygons. Okay, students. Now we'll study about convex polygon. So now we'll study about the convex polygon and concave polygon. Now what is a convex polygon? So it is a polygon, okay, so we'll write is a polygon in which all angles are less than 180 degree. Fine. So this is how we will observe the convex polygon. So these all figures are considered to be as what? A convex polygon. Okay. There is another way of knowing convex polygon is that, so in convex polygon, okay, you will always see the angles are moving outward. Okay, see, V shape, always in the V shape. See, always in the V shape. Right? See, if you see in this way also, see, it is in the V shape, fine, V shape, fine. So all the angles, you will find it is in the V shape. That is moving outward, not inside the figure, but outside the figure. All the angles are going outside the figure, isn't it? And another way is that in convex polygon, the diagonals are always inside the figure. You see, diagonals, these are the diagonals. You know what is a diagonal? Diagonal is the line which joins the opposite vertex. Fine. So you see, these are the diagonals. So diagonals are always inside the figure, students. Fine. So these are some of the points by which you can recognize. So there is no diagonals. We cannot draw diagonals in the triangle, but still it is a convex polygon only. It is not that a figure which is not cutting a diagonal is not a convex polygon. The main part is that the angle should be, the first point is that the angle should be, all the angles should be less than 180 degree. Now, what is a concave polygon? So in concave polygon is a polygon in which at least one angle should be more than 180 degree. Now see the figure carefully. This is the side. Now see this angle is more than 180 degree. Now another one. See like this. Right? So these are all the angles you see. At least one angle which is more than 180 degree. So this angle is more than 180 degree. This angle is more than 180 degree. And even you see that one angle is moving inside. You see in this case all the angles are moving outside the figure, but in this case see at least one angle which is coming inside the figure. See, going inside the figure. Fine. So this type of figures are called concave polygon. And even the diagonals are not, all diagonals are not inside the figure. See, this will be outside the figure. So see, this diagonal is going outside the figure. Outside the figure. Fine. So the diagonals, so in the figure in which the diagonals are can be seen outside the figure, the angles which are moving inside the, at least one angle which is moving inside the figure, or you can say, this is the way you can also remember the concave polygon, that is a polygon in which at least one angle should be more than 180. So this is how you can differentiate between convex polygon and concave polygons to these. Okay, now let's move on to question number 1 of exercise 3.1. So in question number 1, we have some figures and we have to classify them into the simple curve. Which figures will be considered as simple curve, which figure will be considered as a simple closed curve, which are the polygons, which are convex polygon and which are concave polygon. Okay students, so now the first thing that we will answer is which figures will be considered as simple curve. That is number A, simple curve. Now, which are the simple curve? I hope you remember the curves in the figures in which the curves do not intersect. Okay, so the answer would be what? See, 1, 2, 5, 6 and 7. Why not this one? Because you see, when you have to draw this, you have to lift your pen and again you have to draw the another one. So in the figure, when you are lifting your pen to draw it, those figures will also be not considered as simple curve. Now the part B is what? Simple closed curve. It has to be simple also and closed also. That is simple closed curve. Simple closed curve would be what? Same. 1, 2, 3. 1, 2, not 3. 1, 2, 5, 6 and 7. Fine. So these are all simple closed curve also. Okay. Now what is the next one? That is polygons. So what is the polygons? So polygons, the figures which are made up of line segments. So which figures are made up of only line segments? Carefully observe. So those will be only 1 and 2. You see, this is only made up of line segments. So 1 and 2. Fine. Now what about number D? Concave or convex? It is convex. Okay, so in convex, what is it? Convex polygon, you remember? So the convex polygon is a polygon in which all the angles should be less than 180 degrees. So this is the figure, you see, all angles are less than 180 degrees. So only 2. Only 2. And what about concave polygon? I hope you already know the answer. That is only 1. See, one figure. This is more than 180 degrees. Isn't it? So this is the solution of question number 1. Now let's move on to sum number 2. Now in question number 2 we have 3 sums. Okay. Now in each case we have to say that how many diagonals we can draw for each figure. So the first figure they have given convex quadrilateral. Now what is how to draw convex quadrilateral? Now you see 2 words has been used, convex also and quadrilateral also. So what is the meaning of quadrilateral? Quadrilateral means polygon which is having what? 4 sides. 4-sided figure is called quadrilateral. And convex means all the angles should be less than 180 degrees. So mostly all the quadrilaterals that you have studied up till now are convex quadrilateral. So we'll take any one. Suppose this is this one. So this is also a quadrilateral. Why? Because it is made up of 4 line segment and all the angles are less than 180 degrees. Fine. So this is one vertex. Now I said the word diagonals, isn't it? So what is a diagonal, student? So diagonal is a line which joins the opposite vertex. So what is the opposite vertex to this? This one. What is the opposite vertex to this? This one. Fine. Or you can say non-adjacent vertex. Fine. So these are adjacent vertices. These are non-adjacent vertices. Okay. So how many quadrilateral diagonals we can draw? That is 1 and 2. So we can draw 2 diagonals. So you can write here 2 diagonals. Okay. Now regular hexagon. Regular means, I hope you remember what is the meaning of regular. All the sides and all the angles should be equal. In that way only any polygon can be considered as regular. Now regular, what type of polygon? Hexagon. Hexagon. Hexa means 6-sided figure. Fine. So that we have to draw a 6-sided figure in such a way that all the sides should be equal. I'm trying my level best to do that. Okay. So this is almost a regular polygon. Fine. So now this time we have to see that how many diagonals we can draw. So from this point we can draw 3 diagonals. 1, 2 and 3. Fine. And from this diagonal also we can draw 3. 1, 2 and 3. Fine. So 3, and from this 1, 2. Fine. 2 diagonals. So how many diagonals we have drawn? 1, 2, 3, 1, 2, 3, 1, 2. That means 8. There should be another one, and that would be what? This we have drawn, attached. Oh yes, this one. So altogether 9 diagonals, students. 9 diagonals. Okay, 9 diagonals. Now what about triangle? So if this vertex is having any opposite vertex, no. If this vertex is having any opposite vertex, no. If this vertex is having any opposite vertex, no. These are all adjacent vertex, students. All adjacent vertex, but no opposite vertex. So in case of triangle, zero diagonal. You cannot draw any diagonal in case of triangle. Okay. So this is the solution of question number 2, students. That's it for today. Thank you so much. God bless you and take care.